Hey everybody, hopefully this finds you guys. You're happy and healthy and everything. We're gonna go 13.5 law of sines today. We're gonna get through the first 6 examples. We're gonna do guided notes a tad bit different. I'm not gonna fill in everything for you on the board. I'll send you the key for my guided notes, but I'll break down some of the problems to kind of help you out and see if you can follow from there. Try your independent practice and all that stuff. All right, so the law of sines is actually something you guys learned last year in geometry, so hopefully it's kind of a review. So we're gonna look at example number 1. Example number 1, you guys, has A being 100 degrees, little b being 12, and big B equaling 32 degrees. Now the first thing I wanna make sure you know is when you use the law of sines. You use the law of sines if you ever have a combo. And what I mean by that is a side and an angle that match up. So side B, angle B. Once you have a combo, then you know that you're gonna do law of sines. And law of sines states that you can take your side divided by sine of its opposing angle can equal a combo of any other side divided by sine of its opposing angle. So since I have capital A, I'm going to do the sine of capital A. That means I can find side little a. Now, if I cross multiply, I will have 12 times sine of 100 degrees is equal to A times sine of 32 degrees. To get A by itself, I divide both sides by the sine of 32 degrees. And that is what you type in your calculator. Now for the missing sides, I prefer if you just go to 1 decimal place or the 10th place. For angles, we can round to the nearest whole number. So when we do that, you guys, I got a side of 22.3. Now when you look at that though, did we really solve for the easiest piece of the triangle first? We didn't. So you guys, that is how some people just kind of jump the gun real quick for law of sines. I think they automatically have to just use the law of sines. Well, if you're solving a triangle, you want all the missing pieces. So I usually draw something that is not to scale. I know 100 degrees is obtuse, but I still just kind of draw an equilateral triangle. So I could call it A, B, C. I put 100 degrees here. I put 32 degrees here. And I realized the easiest piece would have been to solve for is capital C. So even though that is part of my solution, it would have been easier just to start with the third angle. So angle C is equal to 180 degrees. Take away those two for a final solution of 48 degrees. Now, it really doesn't matter which one you solve for first. It's just easier to get that, so we normally do. Now, the last thing to do is when you start plugging in these pieces, you would have to solve for this guy right here, side C. That's our last one to solve for. So when we do that, we're gonna set up the law of sines again. Again, we would use the combo that we started with, your B combo. So that's my combo I'll use. 12 divided by the sine of 32 degrees is equal to, and now I'm going to use my C combo. Well, I don't know side C, but I do know sine of angle C is 48 degrees. So now you guys, again, I can cross multiply and do all that work. I'll let you do that. Copy it down in my guided notes, but C would equal 16.8. Please make sure that your calculator is in degree mode. So the last thing I like to do though is make sure that it's valid, because you're gonna see that in some of these weird scenarios, you're gonna come up with situations that don't make sense, and then you should not keep that solution. So you guys, the largest angle should have the largest side across from it. The smallest angle should have the smallest side across from it. And then obviously the medium angle should have the medium sized side. And that looks like it would work out. So that's a valid triangle that we made. But the reason why I bring that up is when you do side-side angle, and remember, from your geometry days, that's when you have two sides given, but the angle is not in between them, then there's going to be, it's called the ambiguous case. It's not really clear what's going on, and we're going to see that sometimes it produces a triangle and sometimes it does not. So you guys, I'm going to focus on one of them that works out just fine, okay? One of them that works out just fine is number 4. So when I have angle B is 50 degrees, little b is 10 degrees, and little a is 12 degrees, I know I use law of sines because I have a combo. I got a big B and a little b. That's my combo. But I'll show you why it's side-side angle. And again, it's the bad word backwards, right? So I draw an equilateral triangle, which is not true, but I just draw it like that. And I go A, B, C. Well, B is 50 degrees. Little b is 10. Little a is 12, and that's across from big A, and that's all I know. So see, I have 2 sides, and the angle is not in between them. So this is actually side-side angle information. We always like to read it this way and not that way. I think your geometry teacher told you why. So now that we have that, we know it's a combo. So I set up my B combo. 10 divided by sine of 50 degrees is equal to the A combo, 12 divided by sine of A. So now I'm going to have to cross multiply. I'll show this for the first time here. And it's going to be a 2-step process. Again, follow my guided notes, but I'll divide by 10, and then when I get that solution, I'll have to inverse sine both sides. Doing that leaves me with 67 degrees. So now I can add that to my picture. All right, so now everything's looking okay so far. 50 is smaller than 67, and the side across from 50 is smaller than the side across from 67. You always check to see if your information is kind of matching up with what we know is true. So now that I got 67 degrees here, this is the only time that I will use a rounded answer to find another rounded answer. There's no way to get to the C combo unless I use that rounded answer. So to get capital C, I have to do 180, take away those 2 angles for a solution of 63 degrees. And again, that is technically a rounded answer too. And then now, if I see that 63 degrees is in between those 2 numbers, I better get a number in between 10 and 12, or again, this can't be triangles. But when I set up now I always use my B combo. And that equals my C combo. I don't know little c, but I do know the sine of big C is 63 degrees. I can cross multiply and do all the math. Again, watch copy down from my key, but you're going to get little c is 11.6. Now I already stated that I needed something in between 10 and 12, and it matches up. Biggest angle, biggest side. Smallest angle, smallest side. Medium, medium. So everything works out. All right, I'm going to do one more of the examples with you. You'll be copying down all 6. But we're going to see that if we ever get an error in our calculator, it doesn't produce a triangle, which you will see on example number 5. When you do the inverse sine, it will be an error. No triangle can be made. But there's also another time when you think you can make a triangle, but something fishy kind of goes on, and it's number 3. So when we look at number 3, that should be a capital A, everybody. Capital A, I don't know if it is or not, 70 degrees. Little a is 2, and little c is 11. Well, again, I draw an equilateral triangle, which is not true at all. It's just how I just like to set things up so I see the combos. And I got A, B, C. A is 70 degrees. Little a is 2. Little c is 11. Now, I know I use law of sines because I got a combo. I got an A combo. So I'm going to use that in my first fraction. And I'm going to take side A divided by sine of angle A. And that equals, well, if I got little c, I can do sine of big C. Now, we've already kind of solved the problem like this. You'll cross multiply and you'll do all the math. So when you cross multiply, do that math, you will get capital C is equal to 5 degrees. Now I show more work on the guided notes there. But when I plug 5 degrees right here, an alarm goes off in my head. This is a little silly. 70 has a side 2 across from it. 5 degrees is way smaller than 70 degrees, but he is producing an answer that is larger, okay, or a side across. That doesn't follow our geometry rules, that the smaller angle would have to have a smaller side across from it. So this scenario is not feasible. Please make sure that if you are doing all the correct math and you're coming up with something that just doesn't make sense, that you would realize that this would have no triangle be able to make. Now what I can do is show you why no triangle can be made, because that was incorrect. So what I'm going to do is I'm going to draw the triangle, or I'm going to try to. I'm going to start at angle C and I'm going to go to angle A. Now when I do that, I don't know the distance between the two. So honestly, I'm just going to kind of go like this. But what I do know is 70 degrees is approximately this large, and I'm going to say that is 11 inches. Now I didn't measure it, but we're going to pretend it's 11 inches. And the side across from angle C is 11 inches. Well, the side across from A is 2 inches. If you are proportionately correct, and this is 11 inches long, and you draw something that is 2 inches long, is there any way for a side of 2 across from 70 degrees that is now 11 distance away from this bottom line? Is there any way for this to connect with this bottom line and make a triangle? I hope you realize there is not a triangle that can be produced, okay? That just is not possible. So if you really think about the measurements and the proportions of them, whenever you get no triangle, you should be able to go back and realize why there really wasn't a triangle if you took out a ruler and a protractor and tried to construct the triangle. It's just not going to happen. All right, you guys, so you have the other 3 examples to copy down. A lot more work maybe to show in some of these. But you guys definitely try your independent practice. Now, there are actual tests for the ambiguous case, and I kind of lied to you on number 4. There is a second solution, but that's something that we can only do if we're in class together and get a little, a discussion format. So you guys,